Okay, so here we go. So we're walking backwards. So we've been going 7, 3, 7, 2, 7, 1, right? Yesterday 7, 3, today 7, 2, now 7, 1. Why am I doing it backwards? Well, we'll see. Let's start with this one. So basically they're giving me two equations there. They're giving me 2x minus 3y is minus 5, and 8x minus 9y is minus 11. They give me those two equations, and they want me to find out if the ordered pair 2, 3, is it a solution? Yes or no? It's just a yes/no question. Notice that. I'm just going to bubble yes, or I'm going to bubble no. It's a yes/no question. It's just yes, 2, 3 is a solution, or no, 2, 3 is not a solution. So how do we figure out if it's a solution? What do you do?
Plug it in.
Plug it in. It's just a plug-in. All this, like first three questions in this section are real easy. They're just a plug-in. Now remember, x always comes first, followed by y, right? It's always alphabetical, x then y. Like x comes before y in the alphabet, x comes before y in the point. Plug in the 2 for x, plug in the 3 for y. What do you get? 2 times 2. Well, here, it's got to make them both true, right? So to be a yes, 2 times 2 minus 3 times 3, does that equal negative 5? And down here, I'll plug into this one, and I'll get 8 times 2, 9 times 3. Is that negative 11? So I'm gonna check both of them. Everybody see what I did there? I just plugged in 2 for x everywhere, 3 for y everywhere, and then I just work them both out. If they're both true, it's a yes. If either one of them or both are false, then it's a no. So here we go. 4 minus 9, is that negative 5? Negative 5 equals negative 5, yep. Check. That one's right. Let's try the other one. What's this? 2 times 8, 16. 3 times 9, 27. Yeah, negative 11 is negative 11. Check. They're both right. Our answer is yes. 2, 3 is a solution. Simple, right? That good? Just plug in x is 2, both places, y is 3, both places, work them both out. They're both true. It's a solution. So that one's a yes. If either one of them had come out false, not equal, like negative 4 equals negative 5, that's not true, then I would have said no. Either one, either one. All right. Okay, so number 4 is graphing. Let me write the two equations for us. X minus y equals negative 2. And the other one, x plus y equals 8. Yeah. Okay. So here's the deal. All three of these sections, 7, 3, 7, 2, 7, 1, the ones I'm doing backwards, the reason I'm doing it backwards now, we see, is because it's the same question we're trying to answer 3 different methods to do it. What's the question? How do you solve 2 equations at the same time? 2 equations with 2 letters. How do you solve it? Well, we learned first off by adding them up, right? The addition method, getting something to eliminate. That's the best method. Today, we're going to do the absolute worst method. We're going to graph them. We're going to say, well, you know, you could graph one line and then graph the other and put them on the same axis system, and where they meet, that point of intersection, that'll be the answer to both of them at the same time. And that's true, but that's a lot of work to graph both lines. So that's what we're up against. That's why I did this section last instead of first, because it's the worst method. Okay, so we got a graph. You got to remember, it's good practice though, because we are moving to the final, and the final is only 8 days away, right? So final's a week from tomorrow. You'll be sitting right in here taking the final exam, and that covers everything, including graphing, that we had a couple weeks ago. So it's good to review. How do you graph? How do you take this equation and get a picture, get the line? What do you do first? Get y alone. Yeah, remember that? First, get y alone. To graph, to get a picture, get y alone. So to get y alone, can I start doing some shortcuts just to save time? Just grab that x and jump it to the other side. right? Whenever something jumps to the other side, it just, the sign in the front of it changes, right? It's just a little quicker. So what do we get then? We get negative y is negative x minus 2. That good so far? So when that jumps to the other side, it becomes negative x. The sign in the front changes. That's just like subtracting x from both sides. But I wanted to skip a step and be quicker, right? Okay, now, y is not quite alone. What do we do now to get y alone? Divide by negative 1. So y equals 2 negatives is positive, 2 negatives, positive. Good, we got y alone? We got y alone. So how do we graph it? How do we go from that to the picture? We need 2 dots, right? Remember, you need 2 dots on the graph, on the picture, to get the line. 2 dots, connect the 2 dots to make the line. How do we get the first dot? Yeah, it's the 2. You start with the number out there, huh? Remember that? It's always on the middle, huh? That first dot is on the middle line. Positive is up the middle. Negative is down the middle. So up 2, boom. There's our first dot. Up 2 in the middle. Remember that? Is it coming back? How do you get your second dot? Yeah, it's the slope, which there's nothing here, so it's 1 over 1. It's whatever slope, 1 over 1, is in front of the x's. So that's rise over run. Rise over run, like that. So that means I go up 1 over 1, like that. Up 1 over 1. Is that good? And then connect the dots. So there's the first line. We good there? Maybe I'll make that red since it came from the red stuff. So now, can you do the second one? The blue one? So blue one, same thing. Take the x and jump it to the other side. We got to get y alone. That'll be negative x plus 8. Is that good? When you jump the x to the other side, it becomes negative x. Got to get the y alone. The y's alone. So now you can graph it. So get the first dot. Three, 4, 5, 6, 7, 8. So you start, your first dot's up here at 8. Whoops, is that 9? Is this 8? I'm getting all messed up. Yeah, there we go, that's 8. Okay. So there's 8. And then what do you do from the 8? You got to do, remember, now there's nothing in front of that x other than a minus sign. So remember what you do? You make it 1 over 1, huh? And you let that minus be on the top. Remember, negative on a fraction, it's easiest to put it on the top. So that's rise over run. So you go down 1 over 1. We good there? Then connect the 2 dots, make a line. There we go. Everybody good with that? Are we good? Makes sense how I get the blue line? So start it up 8, and then the slope, there's a minus in front, so 1 over 1, so down 1 over 1. Okay, connect the dots. Now, where do the 2 meet? Well, about right there. Where's that? Can you tell? Can you tell where that is? It's hard to tell, isn't it? This is a terrible method, isn't it? Graphing is the worst way to find the answer to a system. That's why we did it last. It's the worst. If you had to guess, what would you say? How far over? This is 1, probably 2, 3. It's probably over 3. That dot is probably over 3. It looks like it's up 4, doesn't it? It's not, but it looks like it on my poor graphing. It looks like it's over 3, up about 4, right? Isn't this 2, 3, 4? In reality, it's actually up 5, and I've just graphed badly. It's over 3, up 5 in reality. Probably the blue line was, the red line was supposed to come a little higher, and the blue line, you know, it's just messed up. This blue line was supposed to be kind of like more like that, and the red line was supposed to go, woo, like that. There we go. So it's just off. Just off a little bit. So 3, 5. So over 3, up 5. Is really, now how do I know? How do I know it's over 3, up 5? Well, I've already solved the problem. How could you check it though? What if you thought, I think it's 3, 5. How could you check to make sure it's really 3, 5? You could take, let me rewrite the two equations right here real quick from the beginning. You could take the two equations and you could plug in 3, 5. You know what I mean? You could plug in x is 3, y is 5, x is 3, y is 5. It should make them both true. Does it? Does 3, 5 make them both true? 3 minus 5 is negative 2? Yeah. 3 plus 5 is 8? Yeah. It is 3, 5. That's how I knew it wasn't 3, 4. Because if this was 4, that wouldn't work. 3 minus 4 would not be negative 2. And they would not add to be 3, 4, would not add to be 8. See, it's not 3, 4. It's actually 3, 5. Now, when you graph on Math Excel, your graph will look beautiful and perfect. Math Excel will make it, oops, I did 4 again. Math Excel will make it exactly right, so you won't have any trouble telling where it is. You know what I mean? You'll be able to tell. Question?
Do we graph the 3, 5?
Oh, yeah, let me show you. You don't need to do anything. All right, so now they're giving us U and V. So it's kind of weird that they do that. So I'll start with this one here. U equals V. And then the blue one over here. What do you got? 9U is 3V minus 54. Okay. So, well, U and V is weird. You need to know which one's X and which one's Y. How do you know? Look at the x-axis. See what they did there? What do they put right here? What is that? U. So X is U. Right here they put V. V is Y. Does that make sense? It's just alphabetical. X comes before Y in the alphabet. U comes before V in the alphabet. So X is like U. You can tell on the graph. And V is playing the role of Y. So, why does that matter? Well, because what are we supposed to do first for graphing? We're supposed to get what alone? Y alone. You're supposed to get Y alone. How do you get Y? So who's playing the role of Y? V, right? Y is V. So the first thing you're going to do is get V alone. Does that make sense? Just treat V like it's Y, because it is. It's Y. In fact, if it bugs you, so let's just change it. It's kind of bugging me. Let's just change it. Let's do that. Let's just come in here and go, hey. This is X equals Y. And this one, this is 9X is 3Y. Yeah, let's just do that. Why don't we? I mean, who cares? No, it'd be easier. Yeah, just change U to X and V to Y. And just do it like normal. Because that's what they are, right? Yeah, take it from there. That's easier. They'd keep trying to think, hey, what was U again? What was V again? Just change them right in the beginning. The graph will be the same. The graph doesn't know what you're doing. Right? It's just going to be a couple points on the graph. Math Excel doesn't know. Take it from there. So let's graph the red one first. Y's alone, but it's 1 over 1x plus 0. Is everybody okay with that? That makes sense? 1 over 1x plus 0. Right, because that's the same as just x, isn't it? Right, and then we start at 0 and rise and run, right? So when everything's missing, 1 over 1 times x is just 1x, is just x, and add 0. Adding 0 doesn't change anything. Multiplying by 1 doesn't change anything. So that's what we do. You take it from there. So where do you start? You start at 0. That's the origin. So start at 0 on the origin, then go up 1 over 1, boom. So there's the first one. We good with that one? All right, now graph the blue one. So I got that one. Start at 0, go up 1 over 1. So I got the red one. You do the blue one now. Got to solve for y first, right? So solve that blue one for y. Get y alone. Okay, and now for the blue, to get y alone, I'm going to take this minus 54 and just jump it to the other. I'm going to start jumping things now. They change signs, right? So 9x plus 54 is 3y. Last step, divide by 3. So what is that? 3x plus 18 is y. Oh, man, we start up at 18. Okay, that's pretty far up there. So here, we got to get this out of the way, I guess. Here we go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, man, I'm out of room. Because then I'm supposed to go up, right? So there's 18. So there's my first dot way up at 18. And then from there, I'm supposed to go up 3. Up 3 over 1, huh? Up 1, 2, 3. I'm just off the screen. I'm tired of this problem. All right. Let me try again. I guess I got to do better. All right. Let's try again. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. 18. Right there. 18, and then go up 3, 1, 2, 3 over 1. There's your second dot. Okay, there's the blue line. Everybody see that? That was a painful one. So it starts at up 18, right? You start at up 18, and you go rise over run, up 3 over 1. So from 18, you go up 3 over 1, connect the two dots. Now, where do the blue and the red meet? I don't know, way down here somewhere, huh? Can you tell they're going to meet, right? If you keep going, they're going to meet way down here somewhere. Way off my screen, huh? Now, in Math Excel, you'll be able to tell the spots.
Wait, can you even go in Math Excel over if it does exceed over 20? You know,
It won't exceed over 20. Yeah, they're giving you a big enough thing to... Well, I wonder if the 3 would, though, huh? 3, 1, that's 21, huh? Yeah. Okay, finishing this one up, the intersection is minus 9, minus 9. And you get that from Math Excel, right? From the Math Excel graphing, I could tell it was minus 9, minus 9. What if you're taking the test, though? What if you're taking the test and you're like, can't tell on your graph where they intersect, like this one, you know? What are you going to do? Well, you could solve it another way. Remember how a minute ago I solved it using the elimination method or something like that? Just solve it a different way would be my answer. All right, I'm going to move on, since we just don't have time to do every little thing. Okay, let's try this one. This is a valuable one. It goes x plus y is 9 for the first equation. 4x plus 4y is 36. For the second equation. All right, try those two. Get y alone, right? That's always the first thing for graphing. Get y alone there. You guys noticing something funny? So jump this x to the other side. Y equals minus x plus 9. Good there? Make a little more room here. Okay, I can do the graph on that one. So there's that one. Where do we start? Up 9, right? A number off to the right is the starting point. So that's it, up 9. Good. And then where do we go from there to get the second dot? Negative 1 over 1? Yeah, down 1 over 1. Is that good? Remember, so when there's no fraction in front of the x, make it 1 over 1, and the negatives go on the top, don't they? And, right? So that's rise over run. Everybody good? Good there so far? Is that making sense? When there's no fraction in front of x, make it 1 over 1, the negatives go on the top. So that means down 1 over 1, doesn't it? Down 1 over 1. Good. Connect the dots. Okay, let's do the blue one. Did you guys already notice something? Grab the 4x, jump it to the other side. Be minus 4x. Divide through by 4. Y is minus x plus 9. What do you think about that? They're the same, aren't they? They're exactly the same equation. So it's going to be the same line. It's going to start at 9, go down 1 over 1. The blue line is going to be right on top of the red line. So how many intersection points? Yeah, infinite. Infinite solutions, right? Because there's an infinite number of points that intersect both lines. All these points that are on both lines are intersection points. That's what's happening behind the scenes when you get the answer infinite solutions. It's two lines that are right on top of each other. So there's infinite answers. By the way, that is different than saying all real numbers or everything's an answer. Everything's not an answer, right? This dot right here is not a dot those two lines hit. This dot here, this dot here, this dot. In fact, most things are not answers. Yet there are an infinite number of answers. Right? Infinite's not the same as all. There's an infinite number of even numbers, aren't there? But they're not all even numbers, are they? In fact, most numbers are not even numbers. You might think, no, Mr. Aaron, half of them. No, there's a lot of decimals. Most numbers are not even, but there's an infinite amount of even, right? So there's infinite solutions, but not all solutions. It's not all real numbers, is it? It's infinite. Make sense? The difference there? We good? Is that good? Infinite is not the same as all, is it? Have I showed you this before? Maybe I have, and you just tell me if I've done this. That what 0.9 bar means? Did we go over that? Some say no, some say yes. It's hard to know. It was profound in your life if we went over it. Yuri, you said yes. Did we go over this? Did we? Only Yuri remembers? Changed his whole life. Nobody else cared. What is 0.9 bar? Yeah, it means the nines go forever, right? You guys know the bar thing means goes forever? Bar over decimal. Okay, great. So what? What's the big deal with that? 0.9's forever. Well, forever's something. Forever's a little slipperier than you might think. So I'm doing the infinite. We're talking about the infinite solutions versus now 0.9 forever. Is that almost 1.0? Is 0.9's forever almost 1.0? It's not almost 1.0? It's not almost 2. Isn't it almost 1? Isn't 0.9's forever almost 1?
I don't know, I'm scared to answer.
What's that?
I think I don't know, I'm scared to answer.
Scared to answer. Isn't it, is it close to 1 or is it exactly 1?
Close to.
It's close to 1. Right? It's real close. Or is it exactly 1? Is 0.9 bar, 0.9's forever. Forever's a big deal. Is that exactly 1? Is it just close to 1 or is it exactly right on the money? 1. It's exactly right on the money without even a skosh of difference. 1.0. Doesn't seem like it. You're probably thinking, you are nuts, Mr. Heron. But no, I'm right. Let me prove it to you. If they're different, so one more minute here on infinite. I want to show you what infinite does. Infinite goes places that you're not thinking they'll go at first. In fact, in this case, it slips into 1.0 exactly. No, it's 0.9. That's almost 1. It's not. No, it slips. It's there. Let me show you. First off, here'd be the easiest way. What is 0.3's forever? I could prove it to you 3 different ways. 0.3's forever. What? Just a minute ago we talked about that, right? Wait, what's 0.3's forever? Did we just talk about that with the decimal? Sorry, I might be thinking about my other class. Do you guys know what if you get an answer 0.3's forever? What is that decimal? What is that fraction? I'm sorry, I keep saying decimal. What is that fraction? 1/3. Does everybody know that? 1/3 is 0.3. You have a calculator? Take 1 divided by 3. It's 0.3's forever. Have you seen that before? Yeah, 0.3's forever. That's a third, right? You see that fraction 1/3. That's not maybe or close. That's exactly right. 1/3. You know, if you have your calculator, you can check it. 1 divided by 3, hit equals. It'll be 0.3's forever. Okay, so what? Well, what if you add up 3 of them? Well, they're all 0.3's forever, right? So if you add up 3 of them, what is 1/3, 1/3, and 1/3? Say, hey, 1/3 of a pie, 1/3 of a pie, 1/3 of a pie. Got a big pie? Got a big P symbol, huh? 1/3 of a pie, 1/3 of a pie, 1/3 of a pie. How much pie you got? Close to 1 or 1? 1 whole, exact, no skosh of difference, pie. And what's the other side? What's 0.3's forever? 0.3's forever, 0.3's forever. True. 0.9's forever is exactly 1 without in a skosh of difference. You see that? Right? Because isn't 0.3's forever 1/3? So 3 of them is 1. And 3 of these is 0.9's forever, so 0.9's forever is 1. Now if that's not satisfying, got another proof. That's true. I'm not pulling your leg. That's completely true. If you say they're different, how about this? I'll just go direct at it now. If you say, no, they're different, Mr. Heron, they're different. Okay? If 2 things are really different, then you should be able to subtract them and get something. What does it mean if I subtract 2 numbers and I get 0? What does that mean? If I subtract 2 numbers and I get 0, what does that mean? It means they're the same. If there's no difference, they're the same, right? If If I subtract two things, if I go 7 minus 7, the answer is 0 because they're the same. Of course, I mean, that's a silly example. I just want to make sure we agree with that logic first off, because I'm going to pin us with that logic, because that logic's true. If you subtract two things and it's 0, they're the same, aren't they? So let's try subtracting this and this and see what we get. If we get 0, what have I proven? If I subtract them and the answer comes out 0, I haven't proven it yet, but if I can subtract them and the answer is 0, then they're the same, right? So here we go. 1.0 subtract 0.9s forever. That's the trick. If the 9s would just stop, then yeah, it wouldn't be 1.0, but they go forever. So how do you subtract 1.0 minus 0.9s forever? I mean, where do you even start? You're supposed to start on the right side. I mean, I guess these are zeros. How do you start? I mean, it goes forever. There is no right. Right. That's part of the problem. So let's just pretend it said 1 9. Let's just make it easy. What if there was just 1 9? What would the difference be when you subtract? Be 0.1. But there's not 1 9. The 9s go forever. Oh, okay. What if there were 2 9s? What if there were 2 9s? What would the difference be? 0 1, right? $1 minus 99 cents. 0.01, 1 cent, right? Okay, but there's not 2 9s. There's forever 9s. Oh, okay. What if there were 3 9s? What would the difference be? 0 0 1. Right, but there's not 3 9s. The 9s go forever. Oh, okay. What if there were 4 9s? Well, then it would be 0001. You get it, right? But remember, the 9s go forever, don't they? So that means, what's the real answer here? Well, it's zeros forever, and then after the forever comes the 1, right? Well, that's when that 1 finally comes. You with me? Right? Because it's 0, and the last spot is the 1, huh? Well, when does that 1 come? The 1 comes after what? After forever, because there's forever 9s, not just 10 billion, but forever. After forever comes the 1. What if I say, guys, I'm just feeling generous. I'm going to give each of you $10. You guys did well in the exam. I think you did better than my other class. $10 each. And I'll give it to you after forever. When are you getting that money? Yeah, that's Never Never Land, right? After forever. So when's that 1 coming? After forever, meaning it's never coming. Which means the difference between those is, and so those numbers are the same. If you subtract two things and the difference is eggs, those things are the same. They're not close. They are identical. And they are. You type into Google and you get, I'm not pulling your leg. This is true. The forever of the 9 slips it into 1.0. It is exactly 1.0. There is no difference between 0.9 bar and 1.0. They are the same number. They're just written differently. So the forever kind of slips into special things. All right, I just wanted to have a little fun with the forever thing since we were doing the infinite solutions here, showing the difference between infinite and lots of solutions. We're at break time. Let's take a 10-minute break on that note. All right, last one graphing, and then we're up to 7.4. So last one, Fissel, fire up for us. Hello. Are you there? Come in screen. There it is. Oh, I'm on the desktop. The laptop. There it is. All right. So, yeah, let's graph this one. So, x equals minus 1. Y equals minus 5. Can you graph those real quick? Those are quick ones, I think. Graph those two and find out where they intersect. 2 lines, find out where they intersect. Okay, so How do you graph, like when they only have one letter like that? How do you graph that thing? Can't even get y alone, doesn't even have a y. It's only got one letter. How do you graph when they only have one letter?
It's gonna be
Yeah, just go through the x-axis at -1. That's all you do, huh? If it just has one letter, just go right through that axis at that point. So this is the x-axis. Here's -1 on the x-axis. Just zip right through that point. So there it is. There's the line x is -1. Good. And then for the other one, the blue one, we're talking about y. The y-axis is this vertical axis. So -5, 1, 2, 3, 4, 5. It's right here. There's y, -5, so just shoot right through that point. There's y, -5. So where do the two lines intersect? Well, right here. At back 1, down 5, yeah. Clearly, x is -1, y is -5. It's a no-brainer, huh? Right? -1, -5 must be the intersection. Is that good? All right. We are done.